Hello everyone, and welcome to today's webinar, Net Zero in Practice, Insights from Energy Use, Retrofit and Net Zero Research. My name is Ruqayyah Raslan and I'm a professor in Built Environment Decarbonisation at UCL IEDE, and I'm the theme lead for the research theme in Energy Use, Retrofit and Net Zero Carbon.
Hi everyone, my name is Dr. Yorgos Petru. I'm a senior research fellow at UCL IEDE and I'm a co-lead to the theme of energy use, retrofit and net zero carbon. So this year at the Bartlett, we're celebrating 60 years of the environmental design and engineering course. As part of the celebrations, we have organized a series of webinars run by our 8 IEDE research teams.
In addition, we will be soon publishing our book on shaping the sustainable built environment. And to celebrate this, we have a number of other events which will culminate in a one-day in-person symposium on the 8th of October. To stay up to date with all our activities, please sign up to the IED mailing list and follow us on our LinkedIn group, which Yorgos will be pasting the links for into the chat. We'll also be adding the links at the end of this webinar.
We will now proceed with our 2 presentations for the day. Each presentation will last approximately 20 minutes and we will have roughly 15 minutes of Q&A at the end. Please use the Q&A function to post your questions and we'll make sure to pick them up and answer at the end. We will first start with Retrofit Revisit, lessons from 10 case studies over 10 years. This presentation will be delivered by Dr. Valentina Marincioni, who is a lecturer in building physics and program lead for the MSc in Smart Buildings and Digital Engineering. Valentina will reflect on her experience in applying her expertise as an assessor for the groundbreaking Retrofit Revisit project.
Thank you, Yorgos, for this, and thank you, Ruqayyah and Yorgos, for inviting me. Today I'm going to talk about a project that was really, really exciting for us because it was a project where we could really bring some of the latest research together into something that was really practical and really applicable. So it was really, really exciting. And I want to thank Sipsi and Julie Godefroy and Marion Belli from Ken Studio to really support us in this and having us in the team. So yeah, the introduction was great. Thank you, Yorgos. I'm an IED. I'm also part of this team. My research is around retrofit, but it's also around moisture in buildings. So I'm part of UCL and part of the UK Centre for Moisture in Buildings, which we set up in 2016 to improve the way moisture is understood and managed in buildings in the UK. So briefly, I just want to introduce what the UKCMB is, as not many of you have heard of it. The UKCMB is a center that is hosted at UCL, and it works in a rigorous and transparent manner together with partners from academia, government, and industry, and the public to improve the way moisture is understood and managed. This means that we're not doing research for research's sake. We are trying to make an impact, and really we are supporting the industry and the general public to really improve our understanding. Of course, without research, there wouldn't be any UKCMB because there is still a lot to do in terms of research, but I think in our field, there is a lot of applied research that we can do, and we can really strive to have an impact as much as possible. So briefly, I just want to mention what we usually talk about, which is moisture balance. We also have a video on the UKCMB website if you want to have a look at it. So the way we see our buildings is that they are in continuous dynamic balance. And the problem is when you have a lack of moisture balance, and that can lead to health issues and durability issues. But these are just some of the statistics about what is so-called damp and mold. Of course, there's a lot more to just damp and mold. And in the energy follow-up survey by the government, overall, 27% of households reported the presence of some damp and mold in walls and ceiling of their own home, which affects also health of occupants, particularly if they are prone to asthma. So what I'm going to do today, I'm going to show you how we used our research at UCL, not just at ID, but also in collaboration with some colleagues from civil engineering, and how we use that research to really understand more about these buildings. And the project is called Retrofit Revisit. We took 10 case studies from the original Retrofit for the Future project that was more than 10 years ago. It was one of the flagship projects from the government to really look at how retrofit was done with a strong focus on energy efficiency. There were many conversations about carbon at the time, so it was really the focus was really a lot on energy efficiency. And of course, more than 10 years on, we wanted to understand how they fare in broader terms. So our role in looking at moisture was really trying to understand how the durability is and how these buildings are performing 10 years on beyond just energy. But today I'm going to give you a bit of an overview about the project that you can find on the CIBSE website and some of the overall findings, which are always very helpful for anyone who works in retrofit and is interested in that. And then I'm going to show you what we did in terms of moisture and how we did this, and what were the key learning outcomes, the key learning points and key recommendations from that. So the project, again, was led by Julie Godefroy and Marion Belli. And we started as part of the steering group. Rokai and I were part of the steering group. And then from conversations with Julie, they thought, why not doing something more on moisture, which was very exciting for us. We were lucky because we could put together a team at UCL of experts. We had two of the PhD students who were developing some of the methodology that you will see. They were part of this project, which is very good to really see how that expertise can be applied. So there was a publication in 2012, and there was a book by Marion on residential retrofit. And the idea was, actually the idea is to publish a new book with key learning point. I think it's going to be released very soon for any of you who are interested in that. So the idea was to understand what had stood the test of time or any new lessons, particularly looking at moisture, insulation options, and degradation of solutions. So it was just broader than just the building fabric and moisture issues, but of course that was our role. And also there was a second aim of the project, which might be interesting for some of you who look at monitoring and post-occupancy monitoring techniques. So we had a look at different types of building performance evaluation techniques and to see what can be learned with a non-intrusive manner, particularly on the moisture side. We couldn't do any disruption to the building. So it was quite challenging to really find a method that could allow us to do that, because the easiest way would be to drill holes everywhere and use bore scopes and check inside the fabric, but that was something that we couldn't do. So a classic survey couldn't be done. So we had to look at more specific or detailed techniques that could be helpful beyond the project. And also there were some newly developed techniques that were tested, which are beyond moisture issues. So if you're interested in that, have a look at the CIBSE website. So as I mentioned, it was about 10 years ago, more. Probably now it's 11 years. And the approach there was a deep whole house approach that was evaluated at the time, and it included pre and post 1919 buildings, so solid walls, cavity walls, and different types of wall insulation as well, internal wall insulation, external wall insulation. And there were some also interesting and novel approaches that were tested. So these are just the projects that we focused on, and actually the detailed tests that we were working on, which are these ones, the YES, they were a subset of them, particularly on the traditionally constructed building, because what was really interesting, as Historic England was one of the founders, particularly funding the moisture bit, they were interested in understanding if these solid wall buildings after being retrofitted if they stand the test of time. So overall, the core scope covered 10 case studies, but our section of it was the detailed scope, which covered around 5. There was one additional one, which I'll mention later, case study. So if you look at, so these are all the case studies together, and in red is the ones that we went and looked at them. So just briefly, the top one are all the pre-1920 buildings, which we tested almost all of them apart from one. And then we also tested a post-1920 building, which had some interesting issues, and they were interested in having a look at that as well. So we had a, we included that even if it's not a traditionally constructed building. So just to give you a brief overview of what the overall findings are, because I think it's very helpful to put in context what was the moisture analysis and why we did it. The good point of energy use is that there is some increase in energy use compared to the original retrofit after just being retrofitted, but it's often very small and not in all buildings. So, and also it's a significantly lower energy use than the average stock and the same houses prior to retrofit. So from an energy point of view, this retrofit program was really a success. It's still a good performance versus latest approaches like LETI for London and Enerfit. So even more than 10 years on, it can still be a very good standard. And then there were a few things that we couldn't assess because the metering was not fully implemented sufficiently. So again, from an energy use point of view, it's pretty good, all this. There were some changes in air tightness. That was something that the team tested. I wasn't involved. We weren't involved in the air tightness. But the good thing is the team that was carrying out detailed testing were actually going all together. So when they were doing the air tightness test, we could actually also measure the fungal levels, and I'll explain this a bit more later. So from a general air tightness perspective, if we look at the common UK existing buildings, they usually are around 15 cubic meter per hour per meter square. The pre-retrofit were around 11, but the post-retrofit now, well, of this particular retrofit revisit are 2.54. So, which is still very good, with the best being 0.96, which is below Enerfit standard, and the worst to be being more than 7 cubic meter per hour per meter square. So pretty good overall, with some variation. So the reason why, and I'll mention this now, but I'll mention this again. The reason why we were involved during the air tightness test is that when we depressurize a building, we can bring some of the air which is trapped within the fabric. Of course, we can only bring that air that is trapped to the inside of the air tightness layer, but that already can give us an indication, also depending on the location of the air tightness layer and how well the air tightness is being kept, which are well, this kind of findings can really help also understanding if there is anything inside the fabric. And I'll discuss this a bit more in detail later. So something else that is really important about context is whether that temperature, whether those savings are related to still a comfort level that is not according to standards and recommendations. And actually, all of the houses, they have, or the non-houses have a higher temperature than 18 degrees, which is the WHO recommendation, with an average that goes from 18.2 to 20.7 C. And even so, which means that actually we are in comfort condition, although there was not, most homes were rated comfortable by the occupants, even if some of them, they had relatively lower temperatures. So again, on the temperature side, we are not talking about buildings that are underperforming. This is always very important for the context. And then the last bit I'm going to talk about in terms of the general exercise is that all these houses had indoor monitoring. So what our colleagues were looking at if there is any indication of mold growing inside by just looking at relative humidity and temperature. Of course, this is an approach that most people are taking at the moment, but what we will find in this project is that it doesn't give the full picture, doesn't tell the full picture. But of course, it was very useful as we had the data. They found it useful to just plot any mold risk related predominantly to the indoor environmental quality, so to temperature and relative humidity. So what we found as a whole, there was good relative humidity levels in 8 of the 9 homes. And unfortunately, the one with higher relative humidity, we didn't test that. That's a shame. And then there was one home with high relative humidity levels, and it was due to insufficient ventilation. So that wasn't part of our project, unfortunately, but there was a reason for it. And it was relatively easy to identify because it was just related to the indoor environment. And then in terms of our sampling, which is the UCL mold spore sampling in those homes, we found 2 of these buildings to have low fungal and allergen count, which is good. And then 3 of the buildings that we needed to evaluate further. So I'll explain this later, but what I want to mention here is that there was a difference between what this index says, which is purely related to the indoor environment, and what we could find, which is a lot more detailed and considers other factors. And I've talked for too long, but I'll talk a bit about our side, which is the moisture bit. And just want to thank Spiros Eftimiopoulos from Civil Engineering and Toby Cambray from ID, who were part of the team. And briefly, how to tip the moisture balance. Again, we can do it in 3 ways: by looking at indoor sources, which is what that previous mold risk index was looking at. But also we can have mold growing at surfaces due to thermal bridging, due to detailing and leaks and other defects, and also moisture trapped in the fabric. So these are 3 ways to tip the moisture balance. So not talking about the indoor because we've already mentioned that, but if we look at surfaces, that's where we start becoming a lot more complicated. And there's a UKCMB video that you can have a look if you want to learn more about mold. The point of this detail, for example, is that there are so many factors affecting this. So is it too much moisture released into the air, which is related to the indoor air conditions? Is it the room temperature was too low? And this relates to, again, the temperature that we've mentioned. Is the air exchange rate too low? So is the ventilation not working? Or and here again we could learn from what you've seen before. Or do we have a too low surface temperature? And that's when the fabric plays a role. So is the detailing wrong? What's going on? And of course, when we look at broader also moisture transfer through the fabric and the implications of that, we have a huge list of things that can go wrong. This is a quite comprehensive list of causes, and I don't have time to go through this, but I'll suggest to have a look at this guideline from Germany, which is quite comprehensive. So how we did, and I have 3 minutes left. We looked first, we did a screening test, which is our fungal testing. As moisture balance is a result of an interplay of factors, we needed a fully integrated approach. So we did screening first, And then we had more detailed, let's call it further testing that I'll discuss later. Important to think of fungal testing is that it's a screening exercise. It tells us, well, if we have mold is a symptom of something going wrong. It's a potential sign of moisture imbalance. And this fungal testing don't provide a full diagnosis of the problem, but really helps identify where to look and what to investigate. So it's a first step. For those houses where the fungal screening was didn't find any potential issues, we didn't go further in terms of testing. But for those buildings where there were some issues, we had to go further. We did a couple of sampling, air sampling and surface sampling. In particular, the quantification of fungal levels helps identifying how much mold is in the property. And this is the one we did before and after the pressurization. And then the species identification also helps to understand what can be the reasons for that mold growth. Of course, it's not a definite answer, but it gives an indication. And these are the results. We quantified, again, fungal levels. This is the first part, before and after the pressurization. So this is a ratio of fungal levels to allergens, because allergens can be a confounding effect. Okay, so that's why we need to check that. So if the FAI is high, means that the fungal levels are high and much higher than the allergens. So it's a lot more clear that this can be related to mold growth. So this particular property had a ratio that was very high, and this is the one where we needed to do further testing. Then we have this other particular property where both fungal levels and allergens were quite high. And when we did the surface species identification, that suggested high humidity levels, both in the bedroom and in the loft. The last property that had very high ratio, D is the highest ratio, that showed that there was a possible indication of mold in hidden locations. So particularly the species that we found suggested influence of past escape of water events. So there was a leak at some point, and this has led to moisture issues. So overall, these two properties, very few issues. So we didn't go in detail. We didn't look in detail at those two. But now, briefly, sorry for taking so long, but briefly I'll explain what we did in one case for further testing, where we combined building inspection, in situ monitoring, and simulations. This was the building. The building had a number of issues, particularly salt efflorescence at ground floor level, which was likely due to replacing a suspended floor to a solid floor with concrete and EPS. This is the top of the building, where there was a gutter leaking for a number of time. And that suggested that maintenance of gutter is an issue and leaking with rainwater good. So that has potentially led to frost damage. And we did some simulation to evaluate the risk of frost damage, which suggested that the cement pointing that was installed was having a higher impact than the insulation that was installed. So that gave us some ideas on what were the causes for that. And to wrap up, what we found in this further test, we found a design issue, which is related to the suspended ground floor becoming a solid floor. That was the first one. We found a maintenance issue, moisture damage resulting from rainwater goods and exacerbated by inappropriate cement pointing. In that case, internal wall insulation might have a role, but to a lesser extent than the cement. And the main question there was, what about hidden mold? Is there any hidden mold? Because that was what the screening was suggesting. So what was really of concern to the founder was, is there any interstitial condensation? What we could find by sampling a small area was that looking at the pure issue of interstitial condensation, there was no issue. So the issue is potentially more related to rainwater coming from damaged areas. And really what we recommend is to carry out destructive tests near the high level damage to really fully assess moisture risk. So this was useful because some of the hypotheses, particularly around interstitial condensation, were really tested, but also not enough because the number of issues we really require a deeper survey, for example. So in conclusion, and I'll be quick, the important thing is that these are complementary methods. So also the mold risk score at the start could give us some ideas. Resident feedback is also very helpful. Fungal testing, it's a very good way of screening again. And also fabric assessment is required to find the root cause of moisture imbalance. But of course, we were constrained by the fact that we couldn't really drill into the walls. But at least we could find a method that could give us a very good picture of all these buildings. And this is just a few more examples because maintenance became a big issue. And so they mapped maintenance across all the homes depending on tenancy. So if you want to have a look at this, have a look at the full report. Thank you.
Thank you so much, Valentina, for your very interesting presentation. I'd like to remind the audience, if you have any questions for Valentina or for our upcoming presenters, to please post them in the Q&A box. We're now moving on from the domestic sector and retrofit in the domestic sector to the non-domestic sector, where our second presentation is titled Identifying Decarbonisation Pathways for Primary Healthcare Buildings Using Energy Certificate Models. I'm very excited to be introducing this, as this study was just awarded the most significant contribution to art and science of building service engineering at the 2025 SIBSE Ibiza England Technical Symposium, which wrapped up at UCL on Friday. The presentation will be co-presented by Dr. Esfan Burman, who is an associate professor here at UCL IEDE. He's also a chartered engineer and a member of the Chartered Institute of Building Services Engineers, and Nick MacDonald-Smith, who is the Net Zero Carbon Lead at NHS Property Services. Nick has a deep understanding of energy efficiency and sustainability in the built environment, and he's worked in consulting or in-house positions over the last 15 years or so. So I'll hand it over to Esfand.
Thank you very much, Rokhaya, for your introduction. Thank you, Yorgos, Rokhaya, and Velvet for organizing this event. Hello, everyone. This is a two-part presentation, as Rokhaya just mentioned. So I'll just give a brief overview of the technical content of the project. But Nick will add to that from the NHS PS perspective, NHS Property Services, and also a little bit more information about the broader implication of the work and potential future collaborations and also research in this area. So just a little bit of background to set the scene for this presentation, but also to explain the motivation behind the work. I'm sure most of you have come across EPC's energy performance certificates and have been exposed to these certificates or have been basically using these certificates as part of your work or your research. We are aware of the limitations of these certifications, question marks with regards to the accuracy and reliability of ratings, for example, but also consistency between different tools that are used to produce EPCs and so on and so forth. So we are aware of the limitations. Having said that, I think these limitations over the years have led us to overlook the huge potential that exists in the input data that were gathered to produce these EPCs and the standardized format that basically is used to store this data. So just to give you a hint with regards to the scale of the data and the opportunity that this data represents, let's look at the stats that we had up to 2020 for residential buildings. As you can see, at the time, we had around 19 million EPC certificates for dwellings, around 1 million or just short of 1 million, around 900,000 certificates for non-domestic buildings, and certainly more now. So this data really has not been exploited as much. so far. So this distinction between compliance and performance has always been the case. And because we are aware of the limitations, people are a little bit hesitant to use this data for performance purposes and for evaluation of performance in use. So we try to look into this problem to see whether or not we can use this data for performance modeling. And we focus on a sector that is really not explored as much, primary healthcare buildings, in which data collection and development of performance models to identify decarbonization pathways, generally speaking, could be time-consuming and also basically involves, of course, a lot of costs, given the rather small size of buildings and the budget that basically is allocated to this type of projects. So data collection and development of a model could be a bottleneck for this type of properties. And hence this idea of using the models that are already there as part of EPC generation to identify net zero measures at the building level, but also then at the stock level. And the collaboration between IED and NHS Property Services enabled us to get access to the EPC models, the original models that were used to produce EPCs for around 1,000 properties in primary healthcare sector. So that's, if you like, the main aim of the study, to convert these models to performance models and to identify pathways to net zero greenhouse gas emissions. So this is where we were in terms of our baseline certificates, but also the underpinning models. In this case, we were quite lucky because we were dealing with a single EPC supplier that used the single platform, Design Builder software, that provides an interface to Energy Plus. So it was at least theoretically easy, basically, to do this conversion and then use Energy Plus for stock modeling. So that's our baseline or the starting point. We try to develop this type of performance or dynamic simulation models. So to give you an idea of what you can get from the EPC, again, notwithstanding all limitations, I think all of us agree that there's valuable information with regards to the building geometry, the sort of details that is very difficult to capture with alternative methods such as GIS methods when you want to develop a building stock model. And also some useful information in terms of technical building systems, HVAC systems, and generally speaking, building services, that again is not that easy to collect without having access to the building. And if you want to do it at scale, it could be quite expensive. In our attempt to convert these models from Design Builder to IDF files to use in Energy Plus, and before then indeed to do internal conversion from the SPEM module in Design Builder to simplified HVAC module in Design Builder, for those of you who are familiar with Design Builder, we noticed that some information is transferred, notably information with regards to geometry, activity types, and equipment loads. A lot of people believe that equipments are not covered in EPCs, which is not quite true, is excluded from the rating, but there's an allowance with regards to equipment and plug loads to evaluate heating and cooling loads. So that's quite important in terms of evaluation of total energy use outside the rating scheme. So this information was transferred automatically. However, we noticed that a lot of information was missed simply because there was no consistency between the SPEM module and the dynamic simulation module in Design Builder. As a result of that, the software would default basically, or would revert to the default values. So it took us a lot of time to develop a code to be able to get this information, collect this information, and pass it on to IDF files in Energy Plus. So a little bit of detail to explain the extent of the work to develop that code for automation and to enable us to perform this type of simulations at scale. In terms of identification of pathways to net zero, we made the distinction between an intermediate scenario and a stretch scenario. Stretch scenario following the NHS net zero building standard was really a scenario to achieve the NHS specification for net zero buildings and also the targets. But there was an appreciation right from the start, and we tried actually to take a very practical and pragmatic view that is not always possible to get there. There are various barriers in practice, not least technical and economic barriers. So we also introduced an intermediate scenario, which means to update an existing building from its baseline to the latest edition of the building regulations in terms of conservation of fuel and power. So the specifications were updated accordingly, and we try to perform this type of simulations after editing the EPC input files and do some modifications. So here you can see the distinction between the baseline and the intermediate and stretch scenario vis-a-vis different weather files. So weather file for the current climate scenario, but also probabilistic weather files for future. We use the University of Exeter weather files for this type of evaluations. And also, again, taking a pragmatic view, we make distinction between different types of refurbishment packages, starting from light touch measures up to a very deep renovation that includes upgrading of lighting systems, building services, windows, opaque construction, and so on and so forth. So it was a very deep renovation. And this was to give maximum flexibility, of course, to NHS property services and building users to pick and choose the measures that they think would be feasible in a given scenario for a given building. So as you can see, we are dealing with around 1,000 buildings, 39 scenarios per building. So it was an extensive computational exercise to identify these scenarios and their impact. I don't go through all details, of course. We published the methodology and the details in an article in Building Environment. Just to touch on an important aspect of course, the work, and that is the performance gap between modeling results and performance in use. As I mentioned, there are limitations with EPCs, but also more generally, it's not only a matter of just a problem with EPC, but also a problem with uncalibrated modeling. To what extent these projections are reliable. So we had reliable data for a few hundred of these buildings available from NHS Property Services. And as you can see, on average, actually, our modeling projections are quite good. There is a degree of scatter, no doubt. There is a problem of the performance gap, which is a very multifaceted problem. This is a top-down approach. We didn't have access to individual properties, except few case studies that come next. We were not aware of, for example, the quality of maintenance, any issues in practice, control issues, and so on and so forth. Given all these unknowns, I would say that this is quite promising. And again, it's not certainly worse in my experience than the type of uncalibrated performance models that are developed out there in the industry. But these are, again, based on the EPC input files. So we can do this quicker and actually more efficient than building models from scratch, of course. And to have some confidence in terms of our projections, we also identify a subset of these properties for which performance gap was rather low, around 10 to 20% max. And we didn't witness a statistically significant difference between our projections for future scenarios and interventions between this subset and the entire sample. So that gives us, again, some confidence in terms of our projections and the measures that we were recommending for these buildings. Following that, we developed this type of packages and projections for different measures from light renovation to very deep renovation. Under different scenarios, this is under current scenario and the central estimate for a medium emission scenario in 2030 and 2050. We have done a whole set of analysis for other probabilities and a high emission scenario as well, but this is to depict one set of the data, both in terms of energy use intensity and also carbon emissions for the intermediate package and our NHS net zero building under our energy efficiency scenarios. But then when you factor in the potential and opportunity for micro generation, and in this case, we assume that we're going to use PV panels, can see that in some scenarios, we can achieve net zero even on site, regardless of reliance on a future net zero electricity grid that is very often assumed, of course, in the discourse about net zero buildings. So we don't necessarily need to achieve net zero on a site. But as you can see, at least in one scenario here, we have already achieved that in terms of our projections. Interestingly, when you move on to a very deep renovation that encompasses not only building material and technical building systems, lighting, but also HVAC systems, you can see that the result is not as good as the scenario in which building services are not included, and that's because at a very low air tightness, we had to switch to mechanical ventilation and VHR systems, mechanical ventilation with heat recovery. That comes at an expense in terms of EUI, energy use intensity, but there would be a co-benefit in terms of better indoor air quality. So we managed to investigate these type of trade-offs between energy efficiency and the other co-benefits of net zero, in this case, air quality. So we basically completed our analysis at the stock level. Again, a lot of detail is included in that paper, but notwithstanding the limitations that I just mentioned, we also tried to do some detailed studies in 3 case studies representing a small primary healthcare facility, a GP practice, a medium-sized health center, and a community hospital. This is just one of these case studies. This is a GP practice, actually, Silverton practice. And as you can see, the EPC model, for example, in terms of orientation, was not quite aligned with the property. So these types of user, if you like, errors, these type of variations are expected and basically embedded into these EPC data. Some, if you like, misallocation of power densities in terms of defining the activity types or different interpretations of the activity types led, in our view, to EPCs that are, if you like, the baselines that are a little bit overestimating EUI, as you can see, as a result of using higher power densities that had a knock-on effect also in terms of projections for heating energy use. So we made the additions. You can see the discrepancy. Again, this is not unusual, but generally speaking, still, if you look into the trends and the percentage savings, actually, it does make sense. So the idea is not to use the crude data available from an EPC file, but to audit that EPC file and then, of course, utilize that. And we can see some value in doing that. And that could actually address the bottleneck that I just mentioned before in this sector and generally speaking for most building types. Another interesting finding in this project, looking into our energy efficiency measures, but also micro generation, is very often we don't necessarily need to go for a deep renovation to achieve the current net zero targets that are set out in this context for non-domestic buildings. So for example, for this property, upgrading the lighting system from fluorescent to LED and upgrading the technical building systems and transition from gas boiler to heat pump would enable us to get there. Of course, the devil is in the detail, and when we don't basically allow for passive measures, replacing boilers with heat pumps would involve or would imply extending your heating services, your heating terminals, and so on and so forth. So there are all sorts of considerations. And also, as you transit basically to a net zero building, taking into account the impact of a huge, increasing ambient temperature and the risk of overheating, that's if you like, a key decision-making point there, whether or not to go for a technical building system, for a HVAC system that enables comfort cooling, and what will be the knock-on effect on that system, on the EUI as well. So again, in this context, the balance between energy efficiency and achieving net zero target and thermal comfort. So this type of studies and trade-offs were investigated in these case studies. So I've just listed a number of key outputs and lessons. I have already mentioned a couple of them in my narrative. I don't go through all details. Opportunities for future research. I'm sure Nick will also touch on some of these, but from our perspective, research-wise, we certainly think that we really need to now improve this building stock model and move towards development of a more accurate digital twin to complement what we get from EPC input files from GIS, with GIS data and other sources, LiDAR data, for example, to correct any inaccuracies in geometry and so on and so forth. So there are other sources of data that we would be able to use to improve the accuracy of this model. But from a feasibility study point of view, this is already quite promising. Rokhaya just kindly referred to the fact that we won this award actually in the CIPSE Technical Symposium. Huge congratulations and thanks to the lead author of that paper, Meisam, and also all co-authors. And I should also mention that Ji Dong was also the lead author for the journal article in Building and Environment, and it was a huge privilege for me to work with such a talented team. And I'm sure Nick will have his own basically take on this and on the project from the NHS Property Services point of view. But from our point of view, this was a hugely successful and very fruitful collaboration. So at this point, I'll stop sharing because Nick will provide actually the second part of our presentation. Thank you.
Thank you, Esfand. And yes, it was a great privilege to be working with you and your team. So I'm going to whiz through these very quickly. I'm just conscious of time. Obviously, Esfand has covered a lot of the technical detail of the work. I'm going to sort of look at how the work was developed, who we are, and what we're going to do with it. So really, very quickly, NHS Property Services. We are a wholly owned company, public sector company owned by the Department of Health. So we are a limited company, but our sole shareholder is the Department of Health. We were established in 2013, and we own and manage about 3,000 properties, roughly about 10% of the NHS estate across England. So that's the scale of our business. We, along with the rest of the NHS, have a target to achieve net zero carbon by 2040. So that's our ultimate aim and goal. But there is an interim target to reach based on 1990 levels, to reach an 80% carbon reduction based on those 1990 levels by 2032. So this is just setting out where that 1990 level was on the far left, and where that 80% reduction target is on the far right. So and where we were at the end of not last financial year, the year before. We're just collating our data for the 24-25 financial year, but we're making some good progress towards that. So that's kind of our ultimate goal, is to achieve that net zero target. And what I've done, I've developed a net zero strategy. I won't go into these in detail, but there's essentially 4 pillars. The main one, certainly for the purposes of this work, was that first pillar, decarbonisation, energy efficiency, and there's lots of sort of sub sectors underneath all of this, but those are the main elements that I'm looking at across the business. And what I'm doing is I'm splitting the time out to 2040 into these 5 phases, each of those formed of 3 years each. And also, if you're aware of the NHS, everyone has to produce these green plans. In our case, these last for 3 years, and the phase we're just starting now, the first phase, that 25-26 financial year, is also the launch of our next green plan as well. So it all ties in quite nicely. So that's a bit of background. So in terms of where this work came from, it came out of well, we were approached, or we found out that there was a call going up from UCL Partners for the Connecting for Change project in 2023, I believe it was. Sounds a long time ago now. A call for ideas to put forward. So I had seen that we had a lot of EPC models that have been generated by our EPC supplier. And generally, you know, once they're produced, they just sit there for 10 years, or, you know, until they're renewed. But, you know, using Design Builder, which I know had much more technical capability than just producing EPCs, I thought this was a potential that we can, as Esfand mentioned, bypass the whole creating new building models process. If we already had these models sitting around, can we use them? Obviously aware of the limitations around the EPC methodologies and inaccuracies in the whole method of gathering the data and so forth. But essentially, a lot of the base data was there in these models, including the geometries. So is there a way to use these to uplift to DSM Energy Plus models and then carry out more detailed work? So that was my pitch. Esfand very kindly said he was interested, and it seemed to match with some of his previous research as well, and ongoing research. So it was a really good partnership. As I've said, excellent team, and really knowledgeable. And certainly the Connecting for Change process was really good as well, in that it was a short time frame, quick turnaround, some detailed research in a short amount of time, which is great for a commercial business to get that output in a I think it was a 9-month period, which is amazing, and resulting in technical papers and academic papers and so forth. So I can't say enough how grateful I am to the people at UCL for taking this on and doing the research. In terms of how this works for NHS Property Services, what we can do is we can take the original SBEM model for a particular building, and this is just an example. We can then look at the EPC element of that, so how the building performs from an EPC level. But then once we've got that model, we can then, by using the work that Esfand and his team have gone through, we can then place that at the center of some real strategy that we can go through to identify some real good use cases across the rest of the business. So one of the key ones being, can we establish what that net zero EUI would be? And we found that it's about 56 kilowatt hours per meter squared per year, which is in line with some of the Letty and Reba stuff as well. And specifically for primary care buildings, which is important. Also understanding that solar PV becomes an important factor, but we can also then start looking at climate change, climate adaptation implications, overheating assessments, and so forth. But also what we might need to do from a refurbishment point of view. Ideally, we want to do a full package of works. We want to look at the building fabric before we start moving to heat pumps, for example, but that's not always possible practically. We have a really good intervention point, which is when our boilers reach an end of life. There's an opportunity to replace those, and I don't want to miss those. So we sometimes have to do things back to front, and if we do, what are the levels of refurbishment we need to be hitting without having to do the major fabric elements either. So really quickly, next pieces of work, I need to convince the business that I need a design builder license. So that's quite a big one, but I'm making progress there. Next, is it possible to develop that stock-wide model that we can then understand what needs to be done at our buildings, but also across the rest of the primary care estate in the UK as well? How can we identify mitigation methods for future climate adaptation requirements, so overheating, impacts of flooding, higher rainfall, that kind of thing? Can we use the models to understand what can be done there? Should we also be looking to, instead of going to a heat pump that's feeding into an existing low temperature hot water system, should we be moving to air systems anyway, because we might have to do cooling in the future? What's the impact of that? Again, some really interesting analysis that could come out of that. And also we looked only at heat pumps, but we're also looking at things like far infrared heating. So what would be the impact of, instead of using heat pump as a solution, what would a direct electric system like far infrared, how would that perform under these conditions as well? So that's just a really quick summary of the implications for us. And I think for me, it's really understanding the potential that we've got from those EPC models, rather than having to go back to basics, spending a lot of money creating new models when we've got these sitting there. And I think that's a really important part of this. So thank you very much. And I'll hand back to Rukia.
Thank you so much, Nick. And we now have a few minutes for the Q&A, and I believe the first question will be asked by Yorgos. So if you'd like to pick up any questions.
Yes, thank you. The first question is to Valentina from Hector Altamirano. Hector points out the cost of the retrofit, and that even after retrofit, the energy consumption was reduced, but maybe not by the intended amount. So based on this, the question is it still worth retrofitting buildings based on energy criteria alone, or should we start looking at the other criteria such as moisture, health?
Thank you. I agree. Well, I think cost is always an important consideration, but shouldn't be the first one, unless we are in fuel poverty cases. So I think, again, we should put things in context and use retrofit to alleviate fuel poverty, alleviate health, reduce health issues, also to address the climate emergency by reducing our carbon use, and then of course cost is part of the equation, but just one of many. But yeah, I agree. Of course, coming from a moisture perspective, I think health is is the key, but we shouldn't forget the rest.
Thank you.
Thank you so much, Valentina. We had a question for Esfand and the team, which has been answered in the Q&A section, but I have one cheeky last question. Esfand and Nick, you had mentioned that methodology would be replicable for all building types. For the NHS estate and most non-domestic buildings being a bit more complicated, they're using software such as Design Builder to produce EPCs, and there might be a higher degree of let's say, detail in collecting the information when producing the EPCs. What are your thoughts about the domestic sector, where EPCs are usually produced through a much simpler, streamlined process using SAP and might not involve such detail and care? Would it be replicable in that case?
If I answer first, Nick, you might have comments actually to follow. I think so, Rukaya. I mean, again, in this project, of course, we use it in non-domestic context, I must say, but potentially, I don't see any barrier against using it in the domestic sector. If anything, I would say that the level of complexity that, of course, we have in non-domestic sectors, speaking of healthcare, primary healthcare, or in hospitals or commercial offices, is much higher than the domestic sector. So I think actually it's quite useful in domestic sector. Even the level of information that you get on an EPC certificate for a domestic sector is a little bit more detailed on the certificate that you get for non-domestic buildings. So for example, you get some information with regards to building fabric, U values, which is quite helpful, because for this approach, we need to get access to the original model. Potentially that could be a barrier, although all these models and the standardized input files emanating from these models are lodged with the central national register. Unless we have access to that, then we will be in trouble. In this project, of course, we were dealing effectively with the portfolio manager and we had access to the supplier. But from that point of view, because we don't necessarily have access to the input file, for example, the design builder file in all projects, the fact that for domestic EPC, we have more detailed information on the actual certificate is quite helpful. So there might be ways of actually using even that data to develop simplified models, actually, not a very detailed or a dynamic simulation model, but a simplified model to project energy use or to do some simplified calculations.
Yeah, just really quickly. I know that there is a consultation out at the moment to update particularly the domestic modelling process to move away from SAP and include a more detailed domestic modelling process. And in my view, you know, EPCs, if we're using them, they're there. And this is another one of the outputs of the work that I'd like to get to is having one single model for a building that is updated through its life, so that it's you're not having multiple people apply their own biases to it, and that model remains in life. But that's a you know, that's a wish, that's a pipe dream. We'll see. But thank you. Yeah.
Thank you so much, Nick. We've had sort of one more question late in the day. Can I take sort of everyone's permission to ask this last question? Velvet?
Yep.
Yeah, okay. So this was directed to Nick and Esfand. Sohaila Mohammed thanks you, and she is asking about the phased approach to achieving net zero by 2040, which aligns with the NHS Property Services Green Plans with 3-year cycles. She's asking, given the reliance on existing EPC models to bypass new building simulations, how do you plan to address potential data obsolescence or methodological gaps in older EPCs, especially when you're projecting decarbonisation pathways for building, which will evolve or have different retrofits over these multi-year phases?
Yeah, so obviously one of the limitations of EPCs is that it can last for 10 years, and a lot can happen to a building in that time. And this is what I was saying around having almost a live EPC. So if we have access to those models that are produced at the point of the mandatory requirement for an EPC, then we can apply the upgrades, the changes that happen through the life of that building. So that 10-year model becomes a model for life in a way, so that as we replace things, as we upgrade systems in the building, or we add or remove parts of the buildings, that the model is adjusted to reflect that. And in fact, the model is used to model the impact of those works before they're done, so that we get a live ability to understand the impact of the works we might be wanting to do. So yeah, there's in my head there's a lot of benefit of having those models available, and being able to be updated as we progress through the life of a building.
Can I just add? I totally agree with Nick, and a very valid question, by the way. But also, as things stand right now in the industry, when you have deep renovation, very often these EPCs are updated anyway. Because as Nick alluded to, people are interested to see the impact on the rating. There's some commercial interest behind it also, but also sometimes the funding mechanism is linked to that exercise. So yes, they are valid for 10 years, but nothing stops people. And very often when it comes especially to deep renovation, people will opt for a shorter life cycle and would update and replace the EPCs. And that's helpful.
Thank you so much, Esfand and Nick. I think Yorgos might have one final slide to conclude today's webinar.
Thank you, Rukaya. Just for the interest of time, I would like to, I guess, just summarize the slide, which is that I think it's, I hope that everyone has enjoyed today's webinar. And for this reason, we invite you to stay connected. I have shared earlier the links for our mailing list, as well as our LinkedIn groups. I'll share them again. So please do stay connected. And I also wanted to highlight the next webinar of the series, which will be on Tuesday, 3rd of June. And a link to that webinar has also been shared in the chat. Thank you from me. Thank you to the speakers.
Yes.
Thank you.
Thank you. I'd like to thank Valentina, Esfand, Nick for participating in today's webinar, and we look forward to more and more collaborations on the UCL side with all our external partners. And thank you to our attendees and guests. Thank you very much.
Thank you.
Thank you.